Welcome to Rocklin Manufacturing Company, located in Sioux City, Iowa, since 1934. Rocklin is an established manufacturer of industrial electronic equipment. The Rocklin Moldmender micro welder welds metallic ribbon, wire, paste, and powder to repair molds and dies using a solid-state resistance welding process. Typical applications are on plastic injection molds, rubber processing molds, and die casting dies made of steel. The repair areas include parting lines, dents, scratches, corners, edges, pinholes, DC arcs, machining errors, and rebuilding gate and vent areas. Repairs are as simple as placing the appropriate repair material over the intended repair area and pressing down with the Moldmender welding electrode and spot welding the material in place without any arc or excessive heat. There are several advantages to bonding the repair material to the workpiece using this non-arcing spot welding process, as opposed to the more conventional TIG or MIG welding processes. Much less heat is applied to the workpiece. This eliminates distortion, sink, or witness lines. There is no splatter on adjacent areas. No preheating or heat treating afterward greatly simplifies the repair process. This non-arcing welding process makes welding helmets unnecessary. The low voltage output makes the Moldmender safe and convenient. The minimal number of machine settings makes the Moldmender easy to operate. No welding experience is necessary. The equipment is available with either 110 volt or 220 volt power source. Setting up to operate the Moldmender involves connecting the equipment to the appropriate power source, in this case 110 volts. Next, we connect the three cables: the red electrode cable to the red connector, the black ground cable to the black connector, and the foot switch cable to its connector. The Moldmender front panel consists of three sections. The high power section with settings 1 through 4 are used with the 3/32 inch diameter small electrode, and settings 5 through 8 are used with the 3/16 inch diameter large electrode. Second, there is the low power section, whose settings 1 through 6 are used with the 3/32 inch diameter small electrode. Third, the weld speed section has 6 speed selections, which determine how fast the machine will cycle when the foot switch is held down. For our demonstration, I will be on 4 high power, and my weld speed setting will be on setting E. There is also an audio on-off switch, which generates a tone for each weld as it occurs. Next, we will insert an electrode into the holder. There are 2 sizes of electrodes: a 3/32 inch diameter electrode and a 3/16 inch diameter electrode. The smaller 3/32 inch diameter is the one used for most welding, especially on small parts. Note that the end of the electrode is rounded. This is the shape which must be maintained to gain satisfactory welds. There are other situations which called for other shapes, such as a spade shape, which works well for inside corners, and a somewhat pointed end, which works well for very fine welding. These shapes can easily be obtained by sanding or grinding to the desired point. Notice that the electrode holder has a unique ball joint rotary cable, which makes the equipment convenient to operate. The next step is to electrically ground the workpiece with the ground plate. This is one of the most important steps. The workpiece must have as good of a contact with the ground plate as possible. This usually involves clamping the ground plate to a clean surface of the part to be repaired. On large parts, the ground should be as close as possible to the weld area. A heavy part may be able to just sit on the ground plate, but this is not good enough for smaller parts. Next, select a repair material that best fits the application. It should ideally be the same material as the workpiece. We provide repair material in all of the popular mold materials, such as H13, P20, S7, A2, 420 stainless steel, 316 stainless steel, nickel, and so forth. The mold mender will weld any ferrous metal to any ferrous metal. It will not weld non-ferrous metals or materials such as aluminum, brass, or copper. The mold repair materials are available in ribbon form, which is approximately 90 thousandths of an inch wide by 8 thousandths of an inch thick and is sold by the yard. Repair materials are also available in 20 thousandths of an inch and 10 thousandths of an inch diameter wire, also sold by the yard, which work well for scratches, pinholes, and touch-up. There is also paste available, which is a blend of mineral oil and very finely powdered metal. Paste is generally used for very fine repairs such as DC arcs. Metallic powder can be applied using a magnetic electrode, available in 2 diameters. I will be doing an example of a repair on a mold parting line of a plastic injection mold using ribbon material. This is a very common application. The ribbon material may be trimmed if desired or used directly from the spool. Start by positioning the repair material so that approximately 1/3 of its width is hanging over the edge of the parting line. The material can be tacked down at various places along its width, aligning it using the free end. A weld is produced by firmly pressing down with the tip of the electrode on the repair material and then depressing the foot switch. By holding down on the foot switch, the mold mender will automatically keep cycling, thus producing interlocking spot welds up to about 4 times a second. When a curved area is encountered, the repair material can slowly be formed around the curve using slight pressure on the free end of the repair material. Each time the mold mender makes a weld, the repair material is momentarily plastic, allowing you to slightly realign the repair material to follow the curve. Notice that to make a continuous weld, the electrode is rolled slowly enough so that each successive weld overlaps the last. This will bond approximately a 1/32 inch diameter spot each time the unit is triggered. Now go back over this area where the repair material is tacked using the rolling technique to make certain that the material is totally bonded. It doesn't hurt to go over an area that is already welded. So look for any areas that look like they may have been missed. The repair material is in the annealed state before welding, but will be in the hardened state after being bonded in place. It should also be noted that the actual welding is done with the rounded tip of the electrode. Lying the electrode down and welding with its side may increase its contact area and substantially reduces the weld penetration and may produce an inferior weld. An exception to this is now when I want to go back and fold this weld material over the parting line. I can use the side of the electrode along the edge of the repair material. Working on a corner like this requires firm pressure with the electrode to prevent excess sparking. Setting the power to a lower setting can also help. Use the side of the electrode, slightly tipping the handle ahead in the direction that you want to roll it to ensure that the material folds down and not up. This procedure can be repeated as many times as is necessary to form the repair material to the proper shape and minimize finishing as much as possible. Successive layers of metallic ribbon may be welded on top of another. Take care to ensure that each layer is fully adhered to the layer below it before proceeding to the next layer. The repair that is produced is both hardened and permanent. Finishing can be accomplished by any of the standard methods such as grinding, machining, EDMing, plating, polishing, etc. Many of the repairs can be made without pulling the mold from the injection molding machine, thus enhancing production. The 10 and 20 thousandths inch diameter wire, metallic paste, and also metallic powder can be welded to the workpiece in a similar manner to the metallic ribbon which has been demonstrated. For instance, small pinholes and DC arcs may be easily repaired using the metallic paste. Place a small quantity of the paste in the pinhole. Place the electrode so it is positioned in the pinhole and trigger the machine. Next, slightly lift the electrode, allowing more paste to fill the hole. Press down with the electrode and again trigger the machine. Repeat this process until the pinhole area is built up above the surrounding area. Wipe the area clean and then go back over the area, treating the repaired area using the same rolling procedure as described above for a piece of ribbon material. This ensures a dense repair that will finish off exactly like the surrounding mold or dye surface. The Moldmender weighs just 65 pounds and is very portable, allowing repairs to be performed anywhere in the shop. All units are shipped complete, including accessories, welding materials, and instruction manual. For more in-depth information about the Moldmender, please consult the instruction manual.